All right, so moving into module 11. Okay, this section is all about radicals. So, who knows what a radical is? No idea? Can I hint? How about like everything on the warm-up today was a radical. What did all those things have in common? Roots, right? There was a square root, there was a cube root. We could do a fourth root, fifth root, sixth root. Roots. Okay, so roots are radicals. Okay, so 11.1 is all about converting exponential form into radical form. Okay, so let's zoom into this one right here. Okay, so this question right here, I have this form and then I have this form. Let's start. What is this first form right here? Okay, so this is simply exponential form, right, Trey? You see why it's exponential form. It has a exponent. It's not rocket science, not yet. What's this form? Radical form. Okay, so do you see what happened between the exponential form and the radical form? Okay, so this is 27 to the 2/3. It got converted to the cube root of 27 squared. What happened? But what happened? Like, what if I have something totally different? You know, like, yeah, right? The denominator became the root. Okay, so the number that was in the bottom, that tells us what the root is. Okay, so I'm going to write root. Root comes from the bottom. It tells you what kind of root it is. Okay, the 2, the number that was on the top, what did that turn into? The x squared. It still stayed in the exponent, right? Okay, so the 2 stayed up in the top in the exponent. Okay, so notice how they simplified this. Okay, so first they converted it. Notice they put the 27 on the inside and they left the square on the outside. And they did the cube root of 27, which we all know is 3, right? So we got the cube root of 27, which is 3. And then they squared it to make 9. Okay, now notice the difference between the second example. The second example, we have 4 to the 3 halves. Okay, so if I have a 2 on the bottom, what kind of root do I have? A square root. Okay, notice they didn't put a 2 right here, right? You don't have to say a square root. That's implied if you do a radical. Okay, so I have the square root of 4 cubed. What's the difference between this step and this step up here? Yeah, so notice that on this one, they did the exponent on the inside. So they're going to do the exponent first and then break the radical. Okay, so you can do it either way. It doesn't matter which one you do first. Okay, order of operation says you have to do the exponent, which technically the root is an exponent. Okay, so 4 cubed is 64, and the square root of 64, that's a perfect break, it makes 8. Okay, so what I would do if I was you is I'd write this stuff right here into my notes. I'd probably go like this. I'd say we've got exponential form, which is a to the m over n. Okay, and that can convert, and notice it can go both ways, to the radical form. You might write the actual word radical, but I'm a math person, so I abbreviate everything. Okay, so that's going to be the nth root of a, and I can write that in parentheses to the mth power, which, by the way, is equivalent to the nth root of a to the mth, where the m is in the inside. Okay. So that's all we're learning today. Very, very simple. Okay, so let's do a couple examples, review some of our things that we know, properties, and then I'll let you have at it. Okay, so A. Let's start with A. How do you do A? See if you can do it without a calculator, and then I'll show you how to do it with a calculator in case you need a calculator. How would I do this? First, let's convert it into radical form. Okay, so would it be beneficial for us to do the cube root of 125 and then go to the fourth degree? Or would it be more beneficial to do 125 to the fourth degree and then cube root that number?
Oh, no.
You think so? So you know what 125 to the fourth degree is?
No.
God, no. Let's never do that ever. Do you know what the cube root of a negative 125 is? It is. It's negative 5. So let's do that because we can wrap our minds around that. And then let's do the fourth power. Okay? So the cube root of negative 125 is negative 5. Ooh, let's see if you can do this one. Anybody know what negative 5 to the fourth power is? Well, it'd be 25 times 25. Right? I wouldn't expect for you guys to be able to do this in your head. Some people know it off the top of their heads. To be honest, I wouldn't have known that, but I would recognize the number. So at that point, you can just type in negative 5. Now, when you type it in the calculator, how do you type that in the calculator? If you write negative 5, yeah, you need parentheses, right? Because if you just do plain old on, no. Negative, nope, that's not negative, try negative 5 to the fourth. It's going to tell us that the answer is negative 625, but we know better than that, right? You know that if I'm going to go to an even-powered exponent, the negative should cancel out. All right, let's try B. Let's just do, take this sucker, throw it into radical form. What's the radical form of this? The 8th root of x to the 11th power. Perfect. Okay, so you could have written it that way, or you could say the 8th root of x in parentheses to the 11th. Okay, both of those are equivalent. One is not more simple than the other. Okay, so either way works. Let's talk about C. We got the 5th root of 6 to the 4th power.
You just have to solve that.
Yeah, okay, so we're just going to use the calculator to do this. Can we take the 5th root of 6? Anybody know what the 5th root of 6 is? I can tell you it's not very nice, right? The 5th root of 6 is definitely a decimal, something small. So we can't break the 6, but can we go 6 to the 4th power? What's 6 to the 4th power? I don't know what it is off the top of my head. 1,296. Okay, so then you could see if that would be breakable. Can you do the 5th root of, did I write the right number down?
Yeah.
Okay, 1,296. Can you break that? Do you guys know how to do a 5th root in the calculator?
No.
Okay, let me show you. So to do a 5th root or something higher than 3, you type the number. Ooh, good idea. I'm going to talk about that next. But if you want to literally type it as a 5th root, you type a 5th, 5, and then you hit math. And if you use option number 5 down there where it says x root, that's the one we would use. And that'll throw that into our form. And bam. Okay, so is the 5th root of 1,296 breakable? No, we want to leave it in its exact form, so we want to leave it like that. Now, Dawson also said, how can I do a 5th root? To the 1/5 power. Okay, Okay, so you could type it in as 1296 to the 1/5 power. And that might be easier to do than the other way, but same thing, right? Okay, so we're going to leave this as is. Boom. Okay, what about D? Let's go ahead and take D, throw it into the exponential form. What's the exponential form of this? Yeah, x to the 3/4. Okay. So easy, right? Love this section. Okay, let's make sure we got this. Ooh, okay, so here's a couple more things that you need to remember when you're dealing with roots and exponents. If I have a fraction with an exponent, how do I deal with this? Okay, let me go backwards. Let's say I have 2/3 squared. How do you do 2/3 squared? What do you do with that? You just square the top, square the bottom, right? Okay, so that would just be 4/9. Okay, so you would do the exact same thing on this scenario, okay, where you have a fraction. Okay, so this one would be the 4th root of 81 cubed over the 4th root of 16 cubed. Anybody happen to know what the 4th root of 81 is? 3. Nice. How about the 4th root of 16? 2. Nice. So 3 cubed is 27, and 2 cubed is 8. Nice. Now let's be honest. I could have just gone straight into the calculator and typed that initially as I saw it. Okay, so try to do it without a calculator because it's easier. But if you have to use a calculator, then use a calculator. Okay. Okay, what about B? What happens if I have x times y to the 5/3? What do I do in that scenario? The cube root, is that what you mean?
Yeah.
Cube root? Yeah. Did you know, though, that if I keep this in exponential form, this is the same as x to the 5/3 and y to the 5/3? Since both of those pieces are in parentheses, they both have that exponent. Okay, so keep that in mind. Yep. Okay, so that would be equivalent to that. So depending on what the instructions were, if they said simplify this and keep it in exponential form, you would say this works. If they said instead convert it to radical form, then you would say, oh, well, that's just the cube root of xy to the 5th, right? Okay. Okay, let's see if you can do C. And is there a way to do it without a calculator? Okay, so let's think about this for a second. Can I take the cube root of 11? Is that a perfect break? No. Does anybody know what 11 to the 6th power is? Not without a calculator. So how else could I do this problem? What would the exponential form of this be? Ooh, good. So it'd be 11 to the 6/3, right? And 6/3 can be reduced. That's the same as 11 squared. Anybody know what 11 squared is? 121. Nice. We got this. Okay, last one we'll talk about. What about D? Okay, so we're going to simplify this. Okay, so I'm going to cube root it first and see if I can cube root any piece of it. Can I take the cube root of 2? No. Cube root of x? No. Cube root of y? No. What about 2 to the 5th? Nice. So I'm going to have the cube root of 32, and then I have x to the 5th. x to the 5th. On the bottom, I have the cube root of y to the 5th. Okay. Easy peasy? Okay. So, your assignment is on the HMH player. Okay, so you're going to get your tablets out. Try to use Firefox if you can. So log on, Firefox it up, and do 11.1 as your assignment.